Hello everyone, this is Devbyte. In this brand new Unity FPS controller series, we're going to build a complete first-person shooter controller from beginner to advanced. In today's episode, we'll create our basic FPS movement system and smooth mouse look controls. So before we start coding, let's quickly understand how a first-person controller actually works. In an FPS controller, the player mainly does two things: movement using keyboards and camera rotation using mouse. When we press W, A, S, or D, we move the player relative to the direction they're facing. So instead of moving in world directions, the movement follows the player's forward and right directions. Now for the mouse look system, horizontal mouse movement rotates the entire player left and right, and vertical mouse movement only rotates the camera up and down. This creates that smooth first-person look system used in FPS games. Let's create our project and start building our FPS controller. Give a name to your project. In my case, I'm going with FPS controller and select Build in Render Pipeline from Core Templates. And click on Create Project button. Now wait for our project to open in Unity. Let's create a floor for player to walk on. First of all, create an empty game object and name this as environment to keep everything organized in hierarchy. And quickly reset its transform component. Inside this, right-click and create a plane. This will act as our floor. Now, scale it up, change its value in X and Z from 1 to 10. Let's add a simple material for better visibility of the floor. For this, we'll create a new folder in our project folder and name this as 3D. Inside this, create a new folder, name this as materials, and inside material folder, create a new material and name this as floor and assign it to our floor. Now let's create our FPS player, create empty game object, and rename this as FPS controller. Let's add a character controller component. To do this, click on Add Component button and search for character controller and select. You have noticed Unity automatically adds this capsule-shaped collider. Instead of using Rigidbody physics movement, we are using Unity's character controller. Character controller gives us smooth and controlled FPS movement, which is commonly used in first-person games. Now we need a camera for first-person view. We already have a main camera in our scene and we'll use it. Drag it inside our player and change its position to place the camera near the top of the player. I guess we should slightly change color of our floor for better view. Now let's start scripting our movement. Create a new folder and name this as scripts, and create a new folder inside scripts folder and name this as player for organized project. Now inside our player folder, create a new mono behavior script and name this as FPS controller. Now let's add the script to our player. Double click to open it in Visual Studio. Let's start with our basic FPS movement system first. Now, to organize variables in the inspector window, we'll use header for our controller movement setting. Here we're creating a float variable called walk speed. This controls how fast our player moves and set its value to 2. I'm specifically naming this variable walk speed instead of just speed because later in the series we'll also add sprint and crouch movement. So having separate movement speeds keeps our system scalable and easier to manage. Now we'll add a new header for our FPS component references. Next, we need a character controller component. We'll use this for handling our actual player movement. In start, we're getting reference to our character controller component. We get the character controller from the current player object by using getComponent. Now we'll add 2 float variables for our inputs. First, horizontal input. It will handle A and D movement. And second, vertical input. It will handle W and S movement. Writing everything directly inside update will make our script messy and difficult to manage. We'll separate our logic into dedicated methods. First, we're creating a method to handle input. This method will only be responsible for getting player input. First, we will tell our horizontal input is equals input.getAxis of horizontal. Second will be our vertical input, and that is equals input.getAxis of vertical. Inputs, getAxis returns smooth input values between -1 and 1. We will call this method in update because update runs every single frame. This ensures the game feels responsive. Next, we'll create a separate method to handle movement. This method will handle all player movement logic. And inside this method, we'll turn the inputs into movement direction vector. Let's create a vector3 movement. And we simply consider this an arrow that points the direction we want to move. Instead of moving in world directions, we move relative to the player's current rotation, transform dot right handles, left and right movement, and multiply this with our horizontal input, and transform dot forward handles, forward and backward movement, and multiply this with vertical input. So when the player rotates, movement also follows that direction. We normalize the movement vector, so diagonal movement isn't faster than normal movement. Finally, we move the player using character controller. We multiply movement by walk speed to control movement speed, and multiply it with time.delta time to make movement frame rate independent. Save script and test the game. We have our input errors. It's because currently we are using old inputs and the default active input handling is set to be new input. Let's fix this. Click on edit, select project setting, and in project setting, select player setting. And change active input handling to both. Now this will restart our project. Let's test it again. As you can see, when I hold W key, our player is moving forward, and when I hold S key, our player is moving backward. And same for the right and left movement. Let's change our environment for better visual. I just added this environment from the Unity Starter Asset Pack. Let's test the movement control in new environment before moving toward camera look system. As you can see, we have a better feel in movement. Now, let's create our camera look system. Now, for the mouse look system, vertical mouse movement only rotates the camera up and down. Horizontal mouse movement rotates the entire player left and right. This creates that smooth first-person look system used in FPS games. Instead of putting all camera code inside our FPS controller script, we're creating a separate camera look class. This keeps our code cleaner and more modular. And rename this script as camera look. Double-click to open the script in Visual Studio. Now make this class a serializable class. By making this class serializable, Unity allows us to see and edit its variables directly inside the inspector, and we don't need this class to drive anything from mono behavior. Let's add a header for a camera look setting to organize our inspector. Let's add a new float for mouse X sensitivity. This will handle horizontal rotation. Add a same float for mouse Y sensitivity. This will handle vertical rotation. Remove start and update methods. Let's create a new method to handle rotation for a camera and player. Here we'll pass the reference for player transform and camera transform. I guess we spell public wrong. Let's correct this out. Before writing our camera look mechanics, let's call this camera look call in our FPS controller script and check the additional attributes in inspector. Select our FPS controller. Here, as you can see, we have additional attributes for our camera look. Let's write our rotation mechanics. First, add a float for our X mouse input, and it will be equals to input.get axis of mouse X. And we multiply it with X sensitivity and time.delta time for smooth, consistent rotation. Now, we do the same for our mouse Y input and replace X with Y. Now, to store our vertical camera rotation, we'll add a new float X rotation. This helps us clamp the camera so it doesn't flip upside down. We subtract mouse Y from X rotation because moving the mouse upward should rotate the camera upward naturally. Next, we'll clamp the X rotation from -60 to 60. And to do this, we'll use math f.clamp to prevent the camera from flipping too far. This creates a more natural FPS camera movement. And finally, we'll rotate our camera vertically. Camera.local rotation equals quaternion.euler and pass X rotation. And now we'll rotate the entire player horizontally. So now we could have a complete FPS mouse look system. Player body.rotate and pass vector free.up. And back in our FPS controller script here, we'll add a new camera game object. And in start, we'll get its reference by getting camera components from our child camera. Next, we'll create a new private method to handle our rotation. Inside this method, we'll call the handle rotation method from our camera. Look, and here we'll pass this transform as player and player camera transform as camera transform. And call this handle rotation method in our update to track rotation in every single frame. Save the script and hit play button to test controls. Our player can look around and is moving correctly according to directions it's facing. Currently, we have our cursor on screen, and it should be there on screen for FPS games. Let lock and hide cursor with just 2 lines of code. In start, let's set cursor.lock state equals cursor lock mode.locked. And after that, cursor.visible equals false. As you know, currently we are not applying gravity on our player, and that is the reason our player is in midair. Let's add gravity to our player. As we know, gravity is a force that applied over time, and because of this, velocity gradually increased. We need a float for gravity force and set its value to minus 9.81. To apply gravity properly, we first need to know whether the player is touching the ground. To check ground, we'll add a transform for our ground checkpoint, and it'll be at the bottom of our player. Next, we'll add new float for our ground check radius. Next, we'll add a layer mask to detect ground layer. Now let's create non-draw gizmo selected method to visually debug our ground check system. We'll draw a sphere by gizmos.drawSphere at the position of our ground check transform, and radius will be our ground check radius. Let's create an empty object inside our FPS controller and rename this as ground check and set it as position at the bottom. I also created a capsule, our better visibility later. I'll delete it. Now, before applying gravity, we first need to know whether a player is touching the ground or not. Let's create a new method called isGrounded return type bool. Now, inside this method, we'll use Unity's physics.checkSphere function and return the bool. Now, let's create a bool for isGround to store the grounded result. Back in our handle movement method, at very start, we'll store isGrounded method return value in our bool. Now, before implementing our gravity, let's add vector 3 for our velocity. Inside our handle movement script, we'll check if our player is grounded and velocity.y finds 0. Then our velocity.y will be -2. This will check when the player touches the ground, we slightly reset downward velocity. This prevents gravity from continuously stacking while grounded. Now we'll continuously apply gravity over time. Simply increase velocity.y with gravity force and multiply it with time.delta time. And finally, we move the player vertically using our velocity. Set our ground layer as default layer and test the game. As you can see, we have gravity applied on our player. That is it from this video. In next video, we'll add jump, sprint, and crouch system for our FPS controller. Follow Devbyte.